Welcome back, everybody. Today's lesson we're going to be talking about linear equations, and I'm also going to use to demonstrate some of the examples. We'll use a quick way to graph these linear equations using a website called desmos.com, and particularly the calculator. Now it says calculator, however it goes right to the graphing calculator. Desmos has scientific calculator and some other useful tools too, but that's what we're going to be using to help us illustrate the examples. We'll be working out examples by hand, but then we can switch over to desmos.com to see the graphs and see exactly how they work. Alright, so first of all, linear equations, they usually have two variables. They have x and they have y, and then some kind of combination of that. And really, to define a line, it's the set of all points that satisfy a condition, and you'll see what I mean here as we go through the examples. Alright, so we have this equation, 4x minus 3y equals negative 24. Notice this is a linear equation, two variables, the x and y, and we can graph this on a line and find out like where the line intersects the x-axis, known as the x-intercept, or where it intercepts the y-axis, known as the y-intercept. First, I'm going to find the x-intercept by hand. In order to find an x-intercept, we put 0 in for y. Alright, put 0 in for y, and then that just leaves us with one variable to solve, which is x. So let me rewrite it here. Here's 4x minus 3, and here's where the y is, and where the y went, right next to the 3. I'm going to put a 0 in for it. Alright, and if you notice 3 times 0, well, that just gives me 0. So then I'm just left with the simple equation 4x equals negative 24. I'm going to divide both sides by 4. And then that leaves me with negative 6. The x-intercept of this line, it crosses the x-axis at negative 6, which we'll see here in a minute. So yeah, that actual point, x equals negative 6, is where it crosses the x-axis. If we were to say it as a coordinate point, we'd say negative 6 comma 0. When dealing with points, yeah, we know the first one is an x and the second one is a y. So let's switch over to Desmos and let's see how this thing looks. Desmos allows you to type equation in exactly as you see it. No need to solve for y or anything like that. And it is negative 24. There we go. Here's the graph, and Desmos allows you to move it around. You can click and drag, you can zoom out, you can zoom in. And notice the x-intercept. We'll follow it down here, right there. If I click on it, it locks in the point for us, negative 6, 0, just like we said. Alright, so you just have to type the equation in. You could notice the x, and if they wanted to find the y, you could find the y-axis up here at 0, 8. But this question was just the x-intercept, negative 6 as a coordinate point, negative 6, 0. Let's look at another one here. If we found the x, let's find the y. Alright, now to find a y-intercept, we're going to put, this time, do the opposite of what we did before. We're going to put a 0 in for x. So here's solving it by hand. 0 plus 4y equals 15. And 0, don't even have to write, we just have the equation 4y equals 15. I'm finding this is going to tell me where this line, x plus 4y equals 15, crosses the y-axis. I'm going to divide by 4. There we go, y equals 15 over 4. Let's see, 4 goes in there 3 times. There's 3 left over. It's also 3 3/4. So 15 over 4, or 3 3/4, also known as 3.75. The coordinates for this, if we were to, once we see it on Desmos here, we'll write it as a decimal here. 3 3/4, also known as 3.75. So I'm going to make sure you see both forms of this. 3 3/4. We could also write it as 15 over 4. All right, let's have a look at Desmos. I'll just exit out, make a new equation, x plus 4y equals 15. And there it is, graphed it instantly. Here's the y-intercept where it crosses the y-axis, and there's that point that we got, 0, 3.75. Alright, now we're going to talk about finding the slope of a line between 2 points. Finding the slope of the line between 2 points. Alright, so into this one here, we're finding the slope of the line passing through the points -1, 7, and 4, comma, -1. So I'm going to label these x and y. X and y. Now, I'm going to give you a formula here to find the value, the slope of a line. But in order to do this, notice we have two xy coordinates. I need to distinguish them. I'll call this one x1, y1. I'll call this one x2, y2. Now there's a formula called the slope formula, which goes like this. M equals y2 minus y1 all over x2 minus x1. This is the formula for the slope. It tells me the slant or steepness of a given line. I'm going to plug in the values. Notice my y2 was -1. My y1 was 7. I substituted those values in. My x2 is 4, and my x1 is -1. Alright, so -1 minus 7, -8. And 4 minus -1, minus a negative is really plus a positive, so it's just like, kind of like 4 plus 1. Our slope is -8.5. Now that's our slope, and the variable for slope is m. -8 over 5. Slope's always written as a fraction. Tells you the slant or steepness of a line. And the top number is the rise, meaning how much you go up or down. And the bottom number is the run, what we call the run, how much you go left or right. And it's important to know positive is up, negative is down. On the bottom, you can think of positive as to the right and negative to the left. So notice it's -8 over 5. That's like going down 8 and to the right 5. Down 8 and to the right 5. Let me illustrate that here on Desmos. Alright, I'm going to plot these points. Here's how you plot points. You click Add and you go to a table. And our 2 points were -1, 7. See, notice it plotted it right away for me. It's the beauty of Desmos. 4, -1. Okay, so here's our 2 points. Now, there is a line that goes through them. I'll show that line here in a minute. But just if you could, just imagine a line going through them right now. I'm kind of drawing it with my mouse here. If I go from one point to the other, if I go down 8, 1, 2, 3, 4, 5, 6, 7, 8, and then to the right 5, 1, 2, 3, 4, 5. Notice I'm on the line. I'm on the line. Now I'm going to make the equation here. Do y1 equals m x1 plus b. Now what I did here was called slope-intercept form. Notice I pulled from the table the y1. I have the x value, x1's here. Here's the m for slope. B means y-intercept. Here is the line going through it, and we can see it for sure. Notice the slope here, -8/5. -8/5 as a decimal is -1.6. So basically, here we go. You can see a little better the slope of the line. Notice it's going down 1, 2, 3, 4, 5, 6, 7, 8. Then right here, then go 1, 2, 3, 4, 5 to the right from the red dot, down 8, right 5. Down 8, right 5. And that's how I got this -8/5 slope. It tells you the slant or steepness of a line. All right. Just kind of a multiple choice here. Which ordered pair is a solution to this equation? All right. Right way to do this, basically go through. You can test each one. Each value has an x value. The first number is an x, second's a y. One at a time we plug these in to see which one works. Okay, start down here with D. 3x plus 7y equals 13. Is that a true statement? Okay, x is 13 and y is 2. Alright, so this is going to be 39 plus 14. Yeah, that's definitely not going to equal 13. So D's not going to work. Alright, let's try C. 3 times x plus 7 times y. Does that equal 13? Alright, 3 times 4 right here. And then we have 7 times 1. 3 times 4 is 12. 12 plus 7. Nope, that equals 19. That does not equal 13. Alright, then try B here. C doesn't work. D doesn't work. Alright, about 3 times 3 plus 7 times 1, does that equal 13? Well, 3 times 3 is 9, 7 times 1 is 7. 9 plus 7 equals 16, not 13. That leaves us with A. A has to be it. Let's verify. 3 times x plus 7 times y. Does that equal 13? Well, the x is 2, the y is 1. 3 times 2 is 6. 7 times 1 is 7. There we go. 6 plus 7 equals 13. Let's look at this on Desmos, see if that can kind of, we can kind of see it graphically from there. Okay, I'm going to delete what I did before. I'm going to type in 3x plus 7y equals 13. What was that point we were looking at? 2, 1. Let's go to the x-axis and go to 2. Right here, 2, and then here, there we go, right there. Yeah, 2, 1. It Desmos approximates, but there it is. Yeah, right 2, up 1, 2, 1, right there. There it is. We got it. Perfect, perfect. Don't click and hold to see it. All right, now we're going to talk about just some traits of a line here. Let's look at this next one. Select all the statements that are true about the linear equation y equals 4x minus 3. Let's get it graphed on Desmos first. Y equals 4x minus 3. All right, so here we are. It's actually called slope-intercept form. The slope is this number next to x, the 4. The y-intercept is -3. See down here? There it is. All right, let's see. We have the picture. Let's zoom out a little bit if we need to. All right, let's look at the statements. The graph of the equation is the set of all points that are solutions to the equation. That is a true statement. I'm going to highlight this in green here. That is true. Yes. The point 1, 1 is on the graph. Let's go back over to Desmos and look at it. The point 1, 1 is on the graph. Let's zoom in here once to see it. Well, here's right 1. Here's 1 right here. Right 1, up 1. There it is. It's right on the graph. We can see that. Yep, we can also plug those values in, right? So we could do 1 equals 4 times 1 minus 3. I'm plugging in 1 for x, 1 for y. And 4 minus 3, yeah, 1 equals 1. So that means statement B is true. All right, C, the graph of the equation is a single point representing one solution to the graph. No, the graph is a whole bunch of points. Go back to Desmos here and look at this graph. All these points on the purple line here, there's an infinite number of them. Any of these combinations of xy coordinates makes the inequality true. Notice some are decimals. Yeah, there's also several that are whole numbers like 2, 5, 1, 1, like we pointed out earlier. There, let's see if I can get it right there. There's 1, 1. And looks like down here 0, 3 is, yeah, there's the x-intercept, there's the y-intercept. Yeah, Desmos allows you to see that. So this doesn't sound right. It's not a single point, it's a whole bunch of points. And then let's check this very last one here, 0, -3. Let's look at Desmos. Is 0, -3? Yep, there it is down there. 0, -3. We can also verify that algebraically. We'll put a -3 in for y. We'll put a 0 in for x. 4 times 0 is 0, and look at that, -3 equals -3. So we know D, statement D, does satisfy. It is a true statement. So 3 of the 4 statements were all true about this linear equation. All right, hope this video helped a little bit about linear equations and the types of problems you will see with them. Thank you for watching.